Now things are about to get a little more interesting because we're about to solve quadratic inequalities. A quadratic inequality can be written in the form ax squared plus bx plus c is less than or greater than 0, where a cannot be 0, because if a were 0, you wouldn't have an x squared term and then you wouldn't have a quadratic. Now note, they used a less than 0 here, but any symbol will do. What's important is not the symbol, but the fact that we have an x squared here. Before we go through an example together, I'm going to go through the steps with you so you'll kind of understand the process a little bit before we start. So step 1, you need to solve the corresponding quadratic equation. In other words, pretend that your problem is an equation and solve it, and that will give you what we call the critical numbers. Then step 2, draw a number line and divide the number line into intervals using the critical numbers that you just found in step 1. And then, and this is unavoidable, algebra students have been trying to avoid this for forever, but you really can't avoid it. Use a test value from each interval to test something in the interval and see if it makes the inequality true or not. That is the only way. You cannot memorize that less than problems always give us the middle interval and greater than problems always give us the outer two intervals. There are problems where you can memorize things like that. These are not those problems. On quadratic inequalities, it's important for you to test a value from each interval. But here's the good news. If one value from the interval makes the inequality true, then all the values in that interval will make the inequality true. And if one value makes it false, all the values in that interval will make it false. So we only have to test one value from each interval. So here's our first example. It's not a bad one. This says x squared minus x minus 12 is less than 0. So the first thing to do is solve the related equation. In other words, just write the thing as an equation and solve that equation. The two solutions we get from here will be our critical numbers. So let's factor. X squared is going to be x times x. The last times last made negative 12. So let's use a plus and a minus. And we'll need negative 4 and positive 3 in order to get the middle term that we want. Now if this times this is 0, one of our factors has to be 0. Set each factor equal to 0 and solve. And these are our two solutions to our equation. Therefore, these are the critical numbers to the inequality. So draw yourself a number line and label it with the two critical numbers. And what we need to do now is test a number in each interval. So we have this left interval, everything less than negative 3, the middle interval between negative 3 and 4, and the right interval from 4 to infinity. Now this is how I set my table up, and this is the way I hope you'll set yours up too, although I've seen different people do it different ways. What you don't want to do in my math lab is just write true, false, true on your number line. That's not going to be enough work to get credit. So you need to show how you're deciding whether each one is true, false, true. So for my first test value, I'm thinking about the interval from negative infinity to negative 3, and I just need to pick a number that I know is in that interval. And I know negative 5 is in there. And now for the middle interval, it goes from negative 3 to 4. So I need to pick something in between negative 3 and 4, say 0. I always try to use 0 whenever I can. And then I need to choose something in the interval from 4 to infinity. And I'll choose 5 just to stay symmetrical. Okay, now go back through and for each of these test values, plug it into our expression and see whether it makes the inequality true or not. And you know, we really don't care about the numbers so much. As long as you have 0 on the right side, all negative numbers are less than 0 and all positive numbers are greater than 0. So it doesn't matter so much about the number. We only have to care about its sign. So I'm only going to record the sign here. Now negative 5 plus 3 would be negative 2, but I only care that it's negative. Negative 5 minus 4 would be negative 9. Again, negative. Now any negative times any negative is positive. So no matter what test value I use, if I get negative times negative, Is that going to be less than 0? Well, that's a positive number, so no, it's not going to be less than 0. Okay, let's do the same thing for 0. If you plug 0 in here, 0 plus 3 is a positive answer. 0 minus 4 is a negative answer. Positive times negative is negative. And is that less than 0? And the answer is yes, that is less than 0. Okay, now do the same thing for 5. 5 plus 3 is positive, and 5 minus 4 is positive. And positive times positive is positive. And is that going to be less than 0? And the answer is no. So the only interval we found that makes the inequality true is the middle one. So I will shade the middle interval, and I will put brackets or parentheses. Now this is a less than, so it needs parentheses. And our final solution is from -3 to 4. Now make sure, again, when you enter your work in My Math Lab, make sure you type a table, something like this. It doesn't have to look exactly like mine, but it needs to fully justify your answer of why you chose the interval you chose for your answer. And now here's a practice one for you to try by yourself, so pause the video and try it on your own. And if you've done that, now let's go through it together. So first we need to get the critical numbers. We'll need to solve the related equation. So I'm going to factor here. X squared is x times x. The signs need to be different. 6 has got to be 3 times 2. So I'm going to put the 3 here and the 2 here. And now if this times this is 0, then one of the factors has to be 0. The two solutions I get are -2 and 3. So those are our critical numbers. And now I'll need to test something in each interval. And the first interval is from -infinity to -2. And so I'm going to choose -5 as my test value. And the second interval is from -2 to 3. Let's choose 0. And the third interval is from 3 to infinity. Let's choose 5. Remember, just any value that fits in that interval can be used. Alright, so plugging -5 into our factoring, -5 plus 2 is -3. All we care about is that it's negative. And -5 minus 3 is also negative. Negative times negative is positive. Is that greater than 0? Yes, all positives are greater than 0. And now plug in 0. 0 plus 2 is positive. 0 minus 3 is negative. Positive times negative is negative. Is that greater than 0? And the answer is no. And now plug in the 5. 5 plus 2 is positive. 5 minus 3 is also positive. Positive times positive is positive. Is that greater than 0? Yes. Okay, so our two intervals that belong in our solution are the left and the right. And we'll have this interval from -infinity to -2, and this interval from 3 to infinity. And we'll put the parentheses on the endpoints because we do not have the or equal to bar in our problem. And now the interval will be from -infinity to -2, union 3 to infinity. Now let's look at example 6. The only difference between this example and the last one we did is that the factoring is a little more complicated here because of the 2 coefficient, but it's nothing we can't handle. So let's start by trying to solve the related equation. We'll factor this trinomial. The 2x squared will factor into 2x times 1x. The signs need to be different. And last times last is 12. And I'm thinking 4 times 3, but I'm thinking let's put the 4 here and the 3 here so that we don't create a GCF in this parentheses. Now outer plus inner is going to add up to -5x, but we need positive 5x, so I'm going to flip the signs. And now we have our positive 5x for the middle term. And now if this times this is 0, one of our factors has to be 0. Let's set each factor equal to 0 and solve. And our two critical numbers are -4 and +3/2. So I've put those on our number line, and now we're going to choose a test value from each segment. So my first interval is from -infinity to -4. and I'll choose negative 10 to go in that interval. And my second interval is from negative 4 to 3/2, and 0 is a good value in there. And the interval from 3/2 to infinity, I think let's just use 10. Now, one place a lot of people trip up is if they have a fraction, they try to choose a test value that's close to the fraction, and sometimes they'll accidentally choose one that's on the wrong side. So if you're not sure what mixed number your fraction makes, just make sure and choose a value that's way bigger than that. So 3/2, I know 10 is way bigger than 3/2, even if I weren't sure that 3/2 is equal to 1.5. I still would know that 10 is way more. So, just make sure that you don't choose values too close, because sometimes you can mess up. All right, let's test our negative 10 in our factoring. 2 times negative 10 is negative 20, minus 3 is negative 23, but we only care about the negative. And then negative 10 plus 4 is negative 6. Now, any negative times negative would make a positive answer. So is that going to be greater than 0? And the answer is yes. And now let's plug in 0. 2 times 0 is 0, minus 3 is negative, and then 0 plus 4 is going to be a positive answer. Negative times positive is negative. Is that greater than 0? And the answer is no. And then let's plug in 10. 2 times 10 is 20. 20 minus 3 is still positive. 10 plus 4 is a positive number. Positive times positive is positive. Is that greater than 0? Yes. And so the two intervals that we need to shade are the left and the right. So I'll shade those. And I've put the bracket on the endpoints because we have the or equal to line in our inequality. And so now our left interval is from negative infinity to negative 4, bracket, union, and the right interval is from 3/2 to infinity. Okay, here's another practice one similar to the last example that we did. This one is quadratic, and so we'll start by getting all of the terms on one side and writing it as an equation. And I wanted to do that so that I could see how to factor the left side. So the first term is 2x squared. That's going to factor down to 2x times 1x. The signs need to be different, so let's put a plus and a minus in here. And then last times last is 18. So your choices are 1 times 18, 2 times 9, 3 times 6. I know that whatever we choose, we don't need to put an even number here because that would create a GCF. So I've decided to start with the 3 times 6. I'm going to put the 3 here and the 6 here. And now let's add up our middle term. Negative 12x plus 3x adds up to negative 9x. And so our factoring looks good. Now let's set each factor equal to 0 and solve. And so our first solution is negative 3/2 and our second is 6. So those are our critical numbers. And now we'll draw those on our number line. And now it's time to pick a test value from each segment. So our test values, if I pick one that's less than negative 3/2, I could use negative 10, and then pick one that's between negative 3/2 and 6. I could pick 0, and pick one that's bigger than 6, and I'll choose 10. Now plugging 10 into our factoring, 2 times negative 10 would be negative 20, plus 3 is still a negative number. Negative 10 minus 6, still a negative number. Negative times negative is positive, and the question is that less than 0? And the answer is no. Okay, now if I plug in 0, 2 times 0 is 0, plus 3 is a positive. 0 minus 6 is negative. Positive times negative is negative. Is that less than 0? And the answer is yes. And then for 10, 2 times 10 is 20, plus 3 is a positive. 10 minus 6 is still positive. Is that less than 0? And the answer is no, because it's positive. Okay, now with the only segment that makes the inequality true being the middle segment, we'll shade the middle, and then we'll put brackets on both ends because of the or equal to bar, and our solution goes from negative 3/2 to 6.